All right. Okay. Welcome back. We have more CodeForces. So in this game thing resembling a game, I don't know. Um, you're given three piles of stones, and then you have a game where the first player picks a number, and the other player increases the number of stones in one of the piles, but can't use the same pile twice in a row. And then the first player wants to get two piles to be the same height within 1,000 turns, I guess. Um, Doctor says, shoutouts to when we asked for tester difficulty opinions, and we got every possible inversion between problems C, D, E, F, G. So this is going to be interesting. Oh god. All right. All right. So what is going on here? Um, 1,000 turns. Okay. 10 to the 9. So almost. Yeah, it's funny because I think if the starting piles are small, like I feel like the size is doing a weird thing because if you don't have the constraint y's at most 10 to the 12th, all you need to do is like pick y to be larger than say the sum of all the piles, and then your first player will always win. Um, on the other hand, it feels like I'm a little confused with the size. So, 1,000 is okay. Ugh, all right, fine. The constants is numbers on z cubed. Um. Okay. Um. Is there like? So I don't even see how you're supposed to play if the piles are F2. Like if you have Okay, let me play the game with like, let's say the piles are all like 0, 0, 0 mod 2 to start. So then on the first turn you end up with 1, 0, 0. Oh, okay. So okay, the mod is a little weird because I guess you can if two piles are 0 mod 2. Okay, never mind. I don't want mod 2. But I feel like there should be some. I almost think there should be some modulus for which. Okay, what does it look like right before you lose? Like the only way you can lose is if you like just incremented a certain pile. So you like just did here, you have B, B. Like then like the next person adds B minus A and then you, or A minus B. If B is, in fact, if A is greater than B. So none, wait, let me make sure the number is not negative in this statement. Oh, Y is actually, yeah, Y is positive. Okay. So A, B, C, Y are supposed to be positive in the prompt statement. B minus A. Okay, so that's how you die. Wait, no, what am I talking about? If you have A, B, B already dead. Wait, hang on, what the frick? Wait, how do you die? Sorry, this is a lie. You die if you have an arithmetic progression. So if you have A, B, C in arithmetic progression and like A minus B is equal to C minus... A minus B is equal to B minus C. Okay, that's how you can die. If you have this difference the same and you just hit this. Yeah, okay, so the losing state right before you die is an arithmetic progression where you also had to have just increased like the previous number. So like for example, like here, 765 where you just increase 7 is a losing configuration. Okay, so then, okay, how do you get there? So what would force someone to enter 765 or any other? So if I just operated on 7, maybe I should use some numbers to give you. Let's do like, I don't know, 1395 or something, just so that the numbers are a little bit bigger. What would lead someone to end up in a state like that? 1095, 1395. So presumably you didn't come from 995, because if you do, you already just died. So I need like a situation where I have like x, let's say x less than y less than z or something, and then no matter what I add, I end up with an arithmetic progression. Can that even happen? I can't think of any examples. Like, I don't know, man. Yeah, so I'm using box to denote that this was like the previous operating number. 5. So this is losing. Okay, there's two cases, which is that we started with a 5 or we started with the 9 was the previously operated one. So this is like... So if I operate to something to get 13, it was like 13 minus x, 9, which meant that I had to get there by adding x. So I need 13 minus x, 9 plus x, 5 to be an arithmetic progression, which should be possible. 26 minus 2x. Well, someone solve this for me. I don't really wanna... Ah, Shiba. It's not an integer. Fuck. Okay, we're gonna scale everything to make everything an integer, just so I can... Alright, change of plan. Scaling. Right, okay. Okay, so 42 plus x should be equal. Wait, did I fuck up? No, that's fine. 6, 12. Wait, what the fuck? That's literally okay. That's 27, 27, 15. In which case we are already dead. Wait, what? Do I? Okay. Shiba. Okay, so this doesn't actually... Is there any other order? So this is one case, and the other case is if I have something like, I don't know. So we know 39, 12, 27, 15 is a death state. And then the other case is that we just operated on 27. So this is 27. Again, we did something to get to 39. And then if I want an arithmetic progression the other way, it's 15 plus x, 39 minus x. Yeah, I thought there might be a small prime p too, but I want to at least understand what the death state looks like first. But I can't get this to be an AP. like I can't find an example of something where one of the two states, like, yeah, I don't know. I feel like I'm missing a case. It can't be this stupid. Okay, I'm just gonna. Okay, so the sum of the numbers is 81. So for it to be an arithmetic progression, one of the numbers has to be 27. What? No, this case doesn't happen. Okay, that case doesn't happen. Okay, this. Okay, I think the top case is just stupid and never happens. We're just gonna ignore it. I'm interested in this bottom case. In which case, wait a minute. What is going on? Wait, I think I'm high. Isn't this one always an AP? This is always AP, right? Like, no matter what I do. I feel like I'm being baited somehow. This is always an arithmetic progression. But I didn't pick the numbers here at all to be special. Okay, so I think... Okay, okay. So if we're in a situation where, in general, if I have A, B, C to start, and I can cause the... I have to think a little bit about the order, but the idea is that you want to force the one of the numbers to be... Alright, so you can control... whoever's controlling y gets to pick the total sum. So as soon as you can force the one of the numbers to be the... just like... Sorry, what am I saying? Okay, on any turn, you look at the number that was operated on. And if I can... I see. Okay, so there's a size... It's a size thing. So as long as like 3 times C is... Yeah, whichever number is still alive, you want to make sure... Whichever number is not pickable, you want to keep that number and then force the sum of everything to be equal to... 3 times that number. So, yeah, it's actually size only. Like, the only obstruction to losing is based on size, I think. So the mod P thing seems less likely to me than it did at the start of the problem. Yeah, wait. Also, y is bigger than 10 to the 12th. So, okay. You're baiting me. Is this gonna work? Are you trolling me? Like, if I just pick y to equal, like, 10 to the 10 on the first turn, then, the state of the game will be, like, something large. I'm not even going to name the initial numbers. I don't care what they are. Like, anything, 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 some big number, anything, anything. I apologize for the Chinese. Let me just write big. Maybe to, yeah, it's, I don't know. I have this shorthand where I write da and xiao sometimes because they take fewer characters. Anyways, yeah, big number, and then on the next turn, I make it such that y equals like 3 times big, or 2 times big minus big plus number. Shit, I should probably give them names now. So now it's like big x, y, where now they're in arithmetic progression, and okay, is this the state that I wanted? In the earlier one, no, hang on, I wanted the selection to be on big, right? So after I do this, X is the largest one, and then what did I want to do again? Like, let me do some numbers so I can see what's going on. Let's suppose I have like 1000, 10, and like 1990. And I just operated on the 1990. Oh, then you just use 990. Okay. And everything blows up. Okay. Wow, this is gonna be really short. Okay, I guess. Alright. I think that's it. Okay, that's okay. If this is correct, it will be very fast to test. We won't have to spend a lot of time implementing it. So, alright. Let's write some code. Alright. Dude, I love it when I can use Python. I'm so bad with C++. Alright. This is, what did we say this was? 1375? Okay, so, right. Let's see if I know how to use interactive things. So b equals int input. Actually, this is interactive, so I don't even want to bother writing test cases. And we want to be the second player. And then print, first we print n, which will be 10 to the 10. Let me just call it big. And then after that, the second player prints, 1, 2, or 3. Do I print okay. Oh, I need to from sys import standard out. This, okay, I don't know, whatever. Print big. Okay, and then I'll have 3 large numbers. So, oh frick, I equals input. Assert 1 less than I less than 3. Okay, so then I'll have a fucking, oh, this Okay, well, we'll do this manually. If I equals 1, a plus equals I, L if I equals 2. God, the joy, we're writing great code, guys. Okay, and then whichever one is big, then I output the shit. Help. I'm so glad Python doesn't have integer overflow. Okay, and then yeah, okay. If I equals to yeah, this is great code, guys. Definitely learn all your coding habits from what I'm doing right now. Okay, cool. After that, whichever number just got operated on, wait, shit, sorry, I'm the first player, not the second player. Wait, the second player is, okay, print first. Yeah, okay, great. And then I print, so after this, ABC should be an arithmetic progression. And then after that, so because it's arithmetic progression, I should just print the max minus the min over 2, right? I think? Let's see if this is what I wanted to do. Okay, my initial piles will be, 2, 5, shit, I shouldn't have used the number so big. It's gonna be really annoying to type. Well, actually, it's okay. 2, 5, 5, you know, why am I being bothering? Why don't I just submit this as, okay, wait, I should at least, yeah, okay. Yeah, that's a good point. Okay, I should probably at least read the input correctly. First. Okay, I'm playing first, and then like, I pick some pile, and then it's a million. Is that the right number? I have no idea. Okay, anyways, let's add up the standout of flushes. Okay, I'm gonna do this with big equals 100 just to make sure the code actually works before I... okay, so 5, 102, 6, 285, 290, 102, 6. Hang on. Something's wrong. Wait, what did I fuck up? That shouldn't be that small. Shit! What am I smoking? It's not plus equals I. Big. Where? Why? Okay, so 5, 102, 6, and then 5, 102, 203. Sorry, 193. I think that's still wrong. That still doesn't look right to me. How does 3 times big? Did I screw up? Oh, okay. I'm just cloning. Um. This is the wrong name. We're gonna call this T. All right. It's like A plus equals T, big equals A. Okay, yeah. Let's try that again. Okay. So 5, 102, 6. Okay, I think that does what I wanted to. Okay, great. Yeah, sorry. I wrote big both first as a big number and then also as like, yeah, I'm just sloppy. Don't learn from this example. All right. All right. Let's see if this works. Star. ProGamer. Docs. Submit. Yeah, learn to code and don't follow this example. This is not learning to code. This is just like doing math problems that happen to be on CodeForces. Okay, I passed test 1. Alright, I passed test 42. Shit. Yeah, accepted! Okay, we did it. Aren't you glad I made the interaction never makes itself lose? Yeah. Yeah, writing the interactor for this sounds super annoying, honestly. Alright, cool. Alright. So that's your daily dose of CodeForces. Thank you everyone. If you're watching this from YouTube, thank you for tuning in. Stay warm. See you sometime in 2024 when I resume streaming again. What are your opinions? I actually do not think this is really an anti-problem. I think it's like pretty motivated because you're like, okay, what's the state that causes you to lose, and then what's the state right before? So you only need to step back to like 2 steps, and then you're like, okay, that's just what's happening. Like I think the critical moment for me was when I like drew this thing and was like, wait a minute, this just always is an arithmetic progression. I feel like I didn't need to, like, all of this was just like, you know, take a step back, take 2 steps back. Oh wait, this just always works. So I think it's like, yeah. And not trying to get. I think this is fine. I think the statement is like actually reasonable, and then the solution is like, you have to take 2 steps back. If you take just 1 step back, it's not enough. But if you take 2 steps back, you're fine.